Hello Rustaceans, welcome to this video of this Rust series. So today we will build our final project by following the Rust documentation. So today we will build the multi-threaded web server. So we have already built a backend server with the Rust framework exam. However, so today we will not be building it with any third-party framework. Instead, what we will do, we will build the web server by using the TCP and the runtime protocols, as well as we will be exploring about the how we can build the multi-threaded and how we can follow the single-threaded or work with single-threaded environments within the web servers. So let's not waste much time into that. Just have a recap of our previous video. So we have covered the advanced features of Rust. We have explored unsafe Rust, advanced features of traits, the advanced macros. We have learned how we can write our custom macro rules, why the macro rules are important in Rust, how we can use that, how we can work with that, how we can use the pre-existing the macro rules, and so on and so forth. So let's just start with the documentation, and before moving forward, let's just create a new project with cargo new command so that in the meantime we will get back to the documentation. We will explore some of the theoretical knowledge, and then we will back to the hands-on implementation. So let's start with this. Let's just, all right, perfect. So final project, building a multi-threaded web server. It's been a long journey. We have reached to the end of this book. If this in this chapter, we will build one more project together to demonstrate some of the concepts we covered in the last chapter, in the final chapter, as well as recap some earlier lessons. For our final project, we will make a web server that says hello and looks like figure they are displaying this, how we will how this code will work, should be the result or the output. So today we will learn about the TCP, the transmission control protocol, the HTTP hypertext transfer protocol, and then listen for TCP connections on a socket. We have already covered that. We have already learned that what are sockets and how it differs from, let's say, different concepts of event-driven architectures and so on and so forth. So, because we have in the lecture number something like in which we have covered the parallelism and concurrency. So, in that chapter, we have covered the sockets. So, parse a small number of HTTP requests, create a proper HTTP response. We have used the SERDI and SERDI JSON to return the response. We have used, let's say, we have already covered that what are status codes while returning the response from the backend server like 200, 201, 403, 401, and so on and so forth. Create a proper HTTP response, improve the throughput of our server with a thread pool, how we can work with throughput. I did show you my LinkedIn post where someone commented on how we can avoid the bottleneck while working with the web server and whenever we have implemented the mutexes. So if you haven't checked that out, if you haven't explored that concept, you can go watch our previous videos. So before we get started, we should mention two details. First, the method we will use won't be the best way to build a web server with Rust. Community members have published a number of production-ready crates available on crates.io that provide more complete web server and thread pool implementations than we will build. However, our intention in this chapter is to help you learn not to take the easy route because we have already took the easy route and we have already built the web server with exam, but right now we will explore it and we will make the implementation, or we will build this through the custom implementations. Because Rust is a systems programming language, we can choose the level of abstraction we want to work with and can go to a lower level than is possible or practical in other languages. Second, we will not be using async and await here. Building a thread pool is a big enough challenge on its own. without adding in building an async runtime. However, we will note how async and await might be applicable to some of the same problems we will see in this chapter. Ultimately, as we noted back in chapter 17, many async runtimes use thread pools for managing their work. We will therefore write the basic HTTP server and thread pool manually so you can learn the general ideas and techniques behind the grades. So let's just go to the 2.21.1. So let's say building a web server using building a single threaded web server. So we will start by getting a single threaded web server working. Before we begin, let's look at a quick overview of the protocols involved in building web servers. The details of these protocols are beyond the scope of this book, but a brief overview will give you the information you need. So the two main protocols involved in web servers are Hypertext Transfer Protocol, the HTTP, and then the Transmission Control Protocol, yeah, means the TCP. So both protocols are request response protocols, meaning a client initiates a request and a server listens to the request and provides a response to the client. The contents of those requests and responses are defined by the protocols. There should be some kind of protocols in between them. You can consider it as rules. So how we can apply the rules over some kind of uh, let's say if I am working with front end, so what should be the rules to predominantly working on the front end? So let's say which browser supports, let's say, whatever feature, which browser doesn't, and so on and so forth. So TCP is the lower level protocol that describes the details of how information gets from one server to another, but doesn't specify what that information is. HTTP builds on top of TCP by defining the contents of the requests and responses. It's technically possible to use HTTP with other protocols, but in the vast majority of cases, HTTP sends its data over TCP. We will work with the raw bytes of TCP and HTTP requests and responses, listening to the TCP connection. So they have created a new project. I have already did it. So let's just start with the implementation. Let me just remove that. And now we will use the TCP listener from the standard library. So they have what they did. Let me just do one thing. Yes, sir. All right, perfect. So right, that's perfectly fine. It's visible on the screen. Yes, it's visible. Perfect. So let's just quickly recap our older concept. So in the previous concept, what we did, we have listened our web server. Let's consider an example of let's say JavaScript or Express. So we used to do app.listen and let's say port number, let's say 5000, and in that we have had a callback function, and in that callback function we used to, let's say, add a console.log, and let's say server is listening on something port, something. So yes, right here, and then let's say if we take an example of the exam. So what we did, implemented a listener, and then what that listener does, the listener listens to the port number where we have exposed our web server. So now here what we have to do, we have to bind the port number so that we will listen or we will run our web application or the web server on that specific port, and no other application can use that code. Let's say if I'm using, let me just do one thing, or let's just write this by myself. Remove this, and let's say let listener is equals to, and now what we have to do, we have to implement the TCP listener and bind that port. So how we can do that? TCP listener imported from the standard library, and then what this standard library has, the bind, incoming, accept, local address, set, time to live, means it mostly used in the perspective of caching. So let's say if I want, let's consider the browser caching. So let's say uh, I have, let's say, this Rust documentation. So might be the documentation won't be updated regularly. So what I can do, I can cache this documentation in my web browser, or and I will cache the let's say documentation in my browser. Or let's say if I am developing the application, what I will implement the caching. What caching will do, whoever opens that specific web application, let's consider Rust documentation. So let's say whoever opens the Rust documentation, so the browser will cache that documentation, and then let's say if I close my browser and reopen that specific same URL or the documentation, it won't get the latest data from let's say my web server. Instead, what it will do, it will show or display the data that has been cached. So it means time to live, how much time this cache needs to be live into my browser or whatever. So this TTL can be used in multiple perspective, like in caching, or even we are working with another any of the implementations, let's say sockets, how much time it needs to be live in, and so on and so forth. So this can be used in multiple perspectives though. So let's say bind, and I want to bind it 127.0.0.0.1 means localhost. If you want to want, let's say, and now you can use any of the port number. Let me just use 8080 and then dot unwrap, and let's wrap this inside the string. Let's just save it. And now what this listener has the type TCP listener. Let's just explore what this type has, or this type contains. I'm exploring this. It has the TCP, it has the struct, and in that struct we have net imp, and then the TCP listener has been imported into that. Sorry for that. So let's say we have TCP listener struct inner, and we have a socket, and inside that socket we have file dsm. And yes, right here. So let's say um, so yeah, here you can see own file and so on and so forth, the file descriptor, and there are a lot of stuff to explore in that. So if you want to explore this documentation, you can, or the explore the types, you can go and check that out. The implementation of the TCP listener is, let's say, inside that bind we have address will be received as, let's say, IO result, and then the return would be the result and the TCP listener address init, and then init is a separate function here, socket new, and then they are creating a new socket that will be running uh, by, let's say, if I run the command cargo run, so the socket will run, and the uh, port will get bind to it. Let's say whatever port number I will pass in here, it will bind to that, and then it will listen onto that port number. So now let's say, oh, oh mhm. All right, perfect. So let's say for a stream, and inside that stream we have listener dot incoming. Now what it will do, it will get the TCP stream. Let me just show you the exact result of, let's say, after implementing that, unwrap stream dot unwrap, and then let's say print, let's say connection established, same as they did. Save it really quick, and let's just quickly run the command cargo run. What we have here, terminal, and then cargo run. Ta-da-ta-da. Here you can see nothing is here inside the print statement. or the terminal, and then let's say if, let me just copy that, 127 and port number 8080. Let's just run HTTP. Oops. And then here you can see I don't 127.0.0.1 didn't send any data. However, I'm getting the response or the print statement or something printed on our terminal: connection established, and connection established. Now let's say what they are explaining, that they are explaining what TCP listener does, what this bind function will do. So let's say using TCP listener, we can listen for TCP connections at the address 127, whatever port number is. In the address, the section before the colon is an IP address representing your computer. This is the same on every computer. We have already explained these basic concepts. We have already learned that. So don't represent the author's computer. Specifically, we have chosen this port for two reasons. HTTP isn't normal accepted on this port, so our server is unlikely to conflict with any other web server you might have running on your machine, and 7878 is Rust type on a telephone. The bind function in this scenario works like the new function in that it will return a new TCP listener instance. The function is called bind because in networking, connect to a port to listen to is known as binding to a port. The bind function returns a result. We have already explored that what the bind function is, what's inside the implementation of TCP listener, and so on and so forth. The incoming method on TCP listener returns an iterator that gives us a sequence of streams, more specifically streams of type TCP stream. A single stream represents an open connection between the client and the server. A connection is the name for the full request and response process in which a client connects to the server and the server generates a response and the server closes the connection. As such, we will read from the TCP streams to see what the client sent and then write our response to the stream to send data back to the client. Overall, this for loop will process each connection in turn and produce a series of streams for us to handle, and so on and so forth. So let's try running the program, and we have already did it. Browsers also sometimes open multiple connections to the server without sending any requests, so that if they do later send requests, that they can happen faster. When this happens, our server will see each connection regardless of whether there are any requests over that connection. Many versions of Chrome-based browsers like Brave, Chromium is a engine, the browser engine. So whoever wants to use that specific browser engine, you can do that. So Brave is built upon Chromium, or you can say the Chrome's version. For example, you can disable that optimization by using is equals to private browsing mode or use a different browser. So let's just quickly move forward. Reading the request, how we can read the request. Let's say if I have a post request, so how can we get the data from that? Or let's say if I have opened the URL inside the browser, so how we can return some kind of response onto that. So let's implement the functionality to read the request from browser to separate the concerns of first getting a connection and then taking some action with the connection. We will start a new function for processing connections, and in this new handle function, we will read data from TCP stream. So what they are doing right here, so they have created a function, built a function handle connection. And what this handle connection will do, it will take the stream as an function argument, and then the, let's say they are creating a new instance of buffer reader, and then they are passing the stream instance to that HTTP request. The buffer reader dot lines, it's an iterator dot map, and then they are mapping over that. Take while, we have already covered that. So they are looping over. Let's say if there is a result, so if there is a okay result, it will move forward, then take while, and then collect will collect all the iterator data. So let's create a function handle connection, and inside that function, what we will have stream, and what the type would be TCP stream. Let's just import it, and then let's say we will not return anything. We will just directly print the HTTP request. So let's say, let me just press Alt Z so that it will automatically move to the next, like if it's overflowing to the screen. So let's say let buffer reader is equals to buffer reader right here, and the new instance, and inside that we have inner. So instead of inner, we have a stream function or the stream argument, and then let's create a HTTP request. Let's say HTTP request, and the type would be vector of, means this is, let's say, let me just hover over that. What this means, that there is a vector of the type, because it accepts the generic type. So we have passed any specific type. Instead, we have passed the underscore. So let's say buffer reader, and inside that buffer reader we have lines, and inside that lines we have we will map over the response. Let's say result, and then result dot unwrap, means it will panic if there is. All right, and then take while, and inside that take while we will create get a closure, add a closure, and then line dot, if line is not empty, if there is something, then collect it. Let me just add the collect method, and then let me just print the request, what's inside the request. So let's say HTTP request, and I can add a hashtag and then to print the response. And inside that we have, why I'm writing steam instead of stream, and then lines imported from directly buffer reader, and then it's perfectly fine. Let's just quickly retry that. Okay, we haven't used that. So let's just quickly use this function and comment that out, use and pass the stream method here. Why I'm using steam instead of stream. Let me just rerun the browser, connection established, and instead of, we can use, let's say, cargo watch. If you want, you can use it. And here you can see the browser request. So we have a get request from browser, the host name, the URL would be connection keep alive, cache control, max age is equals to 0, no caching involved here, the Google Chrome and the version, and then not a brand, and so on and so forth, the Chromium version here. Section mobile platform Windows, insecure request 1, and the user agent would be Mozilla Windows NT64, and so on and so forth. So these are the pretty much the standard way of returning request. So it's the, you will find this request whenever you call any of the whenever you implement something like web server request. So you will see this implementation. So let's just quickly go back and see, right, see, we bring stdio prelude. What, where is this prelude? No, they haven't implemented that. Prelude means import everything from that specific library, and stdio buffer into scope to get access to traits and types that let us read from and write to the stream. In the for loop in the main function, instead of printing a message that says we made a connection, we now call the new handle function and pass the stream to it. In the handle connection function, we create a new buffer reader instance that wraps a reference to the stream, and the buffer reader adds buffering by managing calls to the stdio read trade methods for us. So this is pretty much theoretical knowledge. If you want to read it, you can pause the video and you can read that out. So we have already, I have already explained it to you, the most major of the major concepts of this video or the this topic. Buffer reader implements, let's say, stdio buffer read trade, which provides the lines method, and the lines method returns an iterator, which will return, let's say, result. If there is an okay statement, let's say, the result will return a string. If there is an okay, and it will return an error, stdio, the standard error, if there is something messing up inside that code. By splitting the stream of that data whenever it sees a new line byte. To get each string, we map and unwrap each result. The result might be an error if the data isn't valid UTF-8. A string is considered unified Unicode, let's say UTF-8, and or if there was a problem reading the sorry, if there was a problem reading from the stream, again, a production program should handle these errors more gracefully, but we are choosing to stop the program in the case of for simplicity. I have already told you we should uh, exit the program gracefully, or we should throw some kind of error instead of directly panicking or add the unwrap method. Depending on your browser, you might see the output slightly different. A closer look at an HTTP request. HTTP is a text-based protocol, and a request takes this format: method, request URI, header CRLF, message body. Let's say if you are using a post request, so you will have to pass some kind of data from data to web server through message body, or you can say the request body. And then the first line is so they are explaining this stuff. The last part is HTTP version the client uses, and then the request line ends in a CRLF sequence. CRLF stands for carriage return and line feed, and which are terms for from the typewriter days. The CRLF sequence can also be written as \r, \n, where \r is a carriage return, and \n is a line feed. So consider it, these kind of let's say sequences are mostly used in the regex as well. So if you are familiar with regex, so you know about the \r, \n, \t, b, \w, and so on and so forth. So note that when the CRLF is printed, we see a new line start rather than \r or \n. Let's say \n means a new line, \t means, let's say, tab, \b means the word, and then so on and so forth. So after the request line, the remaining lines starting from the host onwards are headers. Get requests have no body. And so let's move further, and we have, let's say, so the status code is the standard success response. The text is a tiny successful HTTP response. So here, let's say HTTP 1 1 1. So agar no, there are not, there is no any resultant here. So let me just add a more. Let me just add this line over here. So let's say let response, and write all means write the response into that stream. So instead of printing the request, just as what happened, and for the retry call, cargo run, and then let's just rerun the browser, reload the browser, and here you can, oops, response.s bytes. So let's say you can write something over here in the browser if you want. Let's say you want to write something inside the response, you can write that. So it's what it is doing, it is returning the HTTP 11 and the 200 means success response. So if I want to check this inside Postman, so I can do that and I will see the 200 status code. So let's just quickly open the Postman. So it's right here. Let's just quickly open that. So in the meantime, we can quickly move forward. So here you can see. So let's change the AT remove this, and let's just quickly run this. Click on the send button, and here you can see the 200 OK. The request successful. The server has responded as required. Let's just quickly go back. The first new line defines the response variable that holds the success message data, then we call as bytes. On a response to convert the string data to bytes, the write all method on stream takes a, a reference to the U8 and sends those bytes directly down the connection. Because the write all operation could fail, we use unwrap on any error result as before. Again, in a real application, you would add error handling here instead of directly passing the unwrap in with the result. So with this change, with these changes, let's run and you will see. Okay, now if you want to return the HTML template directly from your browser, how you can do that? So now here they are formatting right here. Starting from that, you are adding the status here. The contents would be directly passed through fs read to string. I'm reading the file, HTML file that I have added, and then the length, contents length, and then they are passing the status line, content length, and then so on and so forth. So if you want, you can let's just quickly create a new file inside my code. So let's say index.html. And if let me just show you how you can directly generate this these meta tag or the basic boilerplate of HTML. Press the shift and add the exclamation mark, and you will see the basic boilerplate of HTML is here, the base with basic template. And if you want, you can let's say pass the h1 with hello, oops, hello, hello world, and let's say paragraph um, list server is running, hello world. All right, let's just save it and quickly instead of response make it status. And then what we have to do, we have to read the contents of our file. So let's say let content is equals to fs colon colon read read to string, and let's just pass the path of our file. So we have index.html, and then dot unwrap. If there is an error reading the file, you can add the match statement here or whatever you want. Let length is equals to content dot length. If you want, you can directly add it here. Response is equals to format, and then format, pass this line directly, copy this. I'm directly copying this right here. Content dot length. All right, my bad. Contents, and then content. Oops, content dot length. I have to just pass. Let's just pass the variable. Let length is equals to content dot length right here, and let's just pass. It will return the usize, and then right here you can write the response as bytes. Status, save it here. Let's just rerun the browser. Why I have opened console? And here you can see not found, no such file or directory. It's the result means the error is here. And then instead of, let's say, passing the returning the custom error, it has the thread has been panicked. We have an error here. So why we have an error? So we have it is unable to find that specific file from the source. So how we can do that? We can, let's just move that outside. Let's just rerun this cargo run, remove that, and it's perfectly fine. It's running successfully. And here you can see the content length is 273 and then the HTML code is here. So if I want to come here, next we use format to add files content as body. So you are formatting, you let's just consider it as you are combining everything to respond to or return to browser. So you can have to write everything you by using the format string. Now validating the request and selectively responding. So right now our browser web server will return the HTML in the file no matter what the client requested. So instead of returning a full file, let's say if I want to return server is running this text only. So how we can do that? Or or I want to return a targeted response. So how you can do that? So if the browser requests any, so before returning the HTML file and return an error, if the browser requests anything, for this we need to modify handle connection as shown. This new code checks the content of the request received against what we know a request for looks like and adds if and else blocks to treat requests differently. So now they have implemented a if condition here. So now you can see request line here, and then buffer reader is reading the lines, and then it's going next, means it's using the next method applied directly on the iterator trade. So we have next method, it will go to the next item, and then dot unwrap and dot unwrap here. So if request line is equals to get HTTP, if this is a get request, then return that, and else you will have to do nothing. For now, it's else statement here because it's not mandatory to return something because we haven't implemented the return statement. So what we can do, we can directly let's just quickly comment this out instead of what we can do. We can let's say let request line is equals to what we can do buffer reader read that buffer, and then inside that buffer we have lines, inside that lines we have next, and then we can implement the unwrap method here for unwrapping, or if there is an error we can panic. And if right instead of passing it here, let's just quickly here if request line is equals to, and then what we have to do, we have to pass, let's say if HTTP, you can pass, let's say if you want post requests to be handled here, you can pass the post here, let status, and let's say else, and for now it's there is nothing implemented right here, and so on and so forth. So you can, there will be no difference in the response for now. And then inside the else, they have implemented the 404 not found there. Let's just quickly paste it here so you can see. Let me just rerun the command so I'll show you how we can. We are calling the get request. We are getting the the HTML template. If I want to run this get request, um, here you can see not found, no such file or directly found. Let me just quickly show you what the error is. Let me just quickly control B. And then what we have here, read to string the 404.html. So we have to add the 404 file. That's a 404. And inside that, oops, 404 page not found. Quickly save it and let's just quickly go on the Postman to test this whether we are receiving the error as expected. So they have, oops, sorry, I don't know what you are asking for. Let's just run this request. Here you can see hello world server is running. What if I try to run with the post method? So let's just quickly run this. And here you can see 404 not found, the status code here, and then the response is 404 page not found. So this is what this code will do. So let's just quickly come here inside this. Let's just close this, close socket.rs, index HTML, and then inside the main.rs file. A touch of refactoring. So what we can do, we can implement the refactoring because you can see the repetition of the code is here. We can implement, let's say, if condition, if block here, so that if there is this thing, so return the index.html. If there is this thing, so return the 404.html instead of repeating the same line of code. So here they have implemented status line and the file name is equals to request line. If this is the get request, then return the OK, and then the file name is here, and then everything is here. So they have pretty much made the code easy and the refactored. So let's just quickly comment everything here and let's just save it. Now here you can see status line file name. If request line is equals to get request, then return this, else return that. And then how we are using it, we can directly use it through status line and the file name. Contents fs read to string, we have to read the file name, whatever file name is coming here. And then length will be of contents length, and the response will be of, let's say, format string, returning the status line, content length, and the contents and the write all. So this is pretty much it. If you want to test this, you can test that out. And then the explanation is over here. So this is pretty much it from that. So now we have already built the single threaded web server. So if I have a single request right here, so we can work with that. So turning our single threaded web server or the server into a multi-threaded server. So how we can work with multi-threaded servers. So right now the server will process each request in turn, means one request is successfully completed, then the second request can be accommodated. So how we can work with, so let's say if I want to run the parallel request and accommodate that, so how we can do that. So let's say right now the server will process each request in turn, meaning it won't process a second connection until the first is finished processing. Let me just show you how it works. All right, so let me just quickly rerun the server so that perfect right here. And let's just quickly mhm, off and here press enter. It's oops, I have pressed the enter on both hands. Okay, so no such file or directory found. Why? Hello, oh, index. Press enter and press enter. One of the browser gets a success response right here. It's this browser got the response first, and then this browser got the response after this connection is completed. So now let's just quickly go to the code, close this terminal, and then let's just go back to the documentation. So now, simulating a slow request in the current server implementation, we will look at how a slow processing request can affect other requests made to our current server implementation. And then here you can see the implementation here. So duration, they have implemented the thread sleep duration from seconds, and then they have implemented the 5 seconds of sleep. So what does this mean? Implements handling a request to sleep with a simulated slow response that will cause the server to sleep for 5 seconds before respond. So this is not the best way to do it. Um, we switch from if to match. Now that we have three cases, we need to explicitly match on a slice of a request line to pattern match against the string literal values. Match doesn't do automatic referencing and dereferencing like the equality method does. The first arm is the same as the if block, and then so on and so forth, and then improving throughput with a thread pool. Now, what we have to do, we have to implement a thread pool. Let's say thread pool is kind of um, there you can consider it as a spool or a box in which we have multiple threads spawned into that box, and then we have to wait for a task to handle. So let's say we will take first task, second, third, and so on and so forth. So let's just quickly read the theory. A thread pool is a group of spawned threads that are waiting and ready to handle a task. There are multiple threads inside that box. I have a task that I want to do with. So let's say this browser wants to um, show the hello world or the to get it. Let's say this browser wants to um, do a get call. So how you can do that? It will one of the thread will take the connection, and then it that thread will work on that. If I want to process the request from that postman, it will one of the threads will come out and process that request. So now the remaining threads in the pool are available to handle any other tasks that come in while the first thread is processing. Any of the thread is processing, and one another connection is coming into that thread pool, and let's say so it the first thread, the processing will not be affected by the second connection. So now, when the first thread is done processing its task, it's returned to the pool of idle threads ready to handle a new task. A thread pool allows you to process connections concurrently, increasing the throughput of your server. So let's say so right here, we will limit the number of threads in the pool to a small number to protect us from DOS attacks. If we had our program create a new thread for each request as it came in, someone making 10 million requests to our server could create havoc by using up our server's resources and grinding the processing of requests to a halt. So let's say any of the attacker wants to attack my server, so it will uh, m- do multiple requests at once. So my server won't be able to handle that much requests. Let's say a million requests coming into my server. So my thread pool might be unable to accommodate all the requests, and then the system will get the halt. So rather than spawning unlimited threads, then we will have a fixed number of threads waiting in the pool. So let's say all of the threads are in use and there is no thread available. So what we can do, we can let's say add some kind of implementation to stop the request, or um, add a sleep, or you can say add a wait so that the connections or the requests coming into my server will not impact the previous processing. Requests that come in are sent to the pool for processing. The pool will maintain a queue of incoming requests. We will maintain the queue. Let's say any of the thread completed its processing. So now the so you consider it as a queue, first in, first out. First request coming in, it will be considered first in must not mean that it will first out. Might be it takes a longer time to process something, and might be get requests will be completed first. So first in means for whatever request coming into the queue first, it will be out to the thread pool, the first one. So let's say each of the threads in the pool will pop off a request from this queue, handle the request, and then ask the queue for another request. With this design, we can process up to n requests concurrently, where n is the number of threads. If each thread is responding to a long running request, subsequent requests can still back up in the queue, but we have increased the number of long running requests we can handle before reaching to that point. So if you can remember the um, algorithm of first in, first out, round robin, and so on and so forth. These are not only limited to your operating system. These concepts can come in, and you can understand this theoretical paragraph by remembering that specific uh, phenomena, or you can say the algorithm I have explained you in previous videos. So it will help you a lot to easily learn these concepts, and you will blown up with the concepts that how I'm thinking out of the box to handle any of the task I'm getting into. So let's say I have a system design. I want to design a system, so I have to think in a way that it can be handled in a multiple ways, and aggressively and progressively, you can say. So let's say there should there must be some edge cases, but these edge cases must be you can say the you, these edge cases must be, you can say, you have already worked on these edge cases. So I don't exactly remember the exact word. So this technique is just one of many ways to improve the throughput of a web server. Other options you might explore are the fork join model, the single threaded async IO model, and the multi-threaded async IO model. If you are interested in this topic, you can read more about the other solutions and try to implement them with a low level language like Rust. All of these options are possible, and then so on so forth. Spawning a thread for each request. So let's say if I want to spawn a thread for each request individually, so you can create a thread spawn and then the handle connection. So you can do that. Creating a finite number of threads. So let's say if I want to limit the thread pool, so you can pass, let's say, create a thread pool, a new instance of pool, and then you can pass how many number of threads should be in the specific thread pool. So I have passed four, so the thread pool will accommodate four requests at a time, or the four connections at a time. Pool dot execute handle connection stream. We use thread pool new to create a new thread pool with a configurable number of threads, in this case four. Then in the for loop, pool.execute has a similar interface as thread spawn. That it takes a closure. The pool should run for each stream. We need to implement pool.execute to take, so it takes the closure and gives it to a thread in the pool to run. This code won't yet compile, but we will try so the compiler can guide us on in how to fix it. So you can implement. So now use of undeclared type thread pool. Great, this error tells us we need a thread pool type or module. So we will build on one now. A thread pool implementation will be independent of the kind of work our web server is doing. So let's switch hello crate from a binary crate to a library crate to hold our thread pool implementation. So now we have implemented the library crate here, and they have created a struct named as thread pool. So let's just quickly do this. lib.rs, and here you can see pub struct, and you can pass the thread pool. Let's just quickly save it and comment this implementation in the main function. So let's say let pool is equals to thread pool, thread pool. Oh, okay. Now inside that we have new, we have, and now you can, what you can do, you can run or a for loop here. Here you can see the for loop stream. You can iterate over the stream. So let's say for stream in listener dot incoming. We have already covered that what incoming is. So let's say let stream is equals to stream dot unwrap and then pool dot execute. We haven't implemented that method. We have to implement that. If I will directly run the code here, it will return an error, throw an error. Let's just quickly save it and let me just try to run this code. Here you can see function or associated item not found in thread pool, the new implementation, the method. So here you can see pub struct thread pool, and now they are implementing the new function, which what it will do, it will return the thread pool means the struct. So let's say implement thread pool, and inside that we have a new function, and inside that we can take number of you can say the pool or the threads I want to accommodate or create. So thread pool, we should have to implement a for loop to create multiple threads. Here you can see pool dot execute no method found. So here what they have. So now the error occurs because we don't have an execute method on thread pool. Recall from creating a finite number of threads that we decided our thread pool should have an interface similar to thread spawn. In addition, we will implement the execute function. So it takes the closure it's given and gives it to an idle thread in the pool to run. So now we will define the execute method on thread pool to take a closure as a parameter. Recall from whatever the topic is in, let's say, 13.1, the closure in chapter 13, that we can take closures as parameters with three different traits: function, function mute, and function once. We need to decide which kind of closure to use here. We know we will end up doing something similar to the standard library implementation. So we can look at what bounds the signature of thread spawn has on its parameter. The documentation shows us the following. So here you can see the spawn method where we have f as function once, or the f as send plus static, and the t as send or static. And now let's just implement the execute here. We have passed the function once. F type parameter also has the trade bound send. Let me just function type parameter is the one we are concerned with here. The type t type parameter is related to the return value, and we are not concerned with that. And we can see that spawn uses function once fn once as the trade bound on f. This is probably what we want as well, because we will eventually pass the argument with get in execute to spawn and then so for this is pretty much theory validating the number of threads in a new. So we have to validate how many number of threads can be accommodated or they created. So they have implemented the size must be greater than 0. Function build, you can build add a function build which will get the size and return the result as the thread pool if there's a success or pool creation error. And here you can see pub struct. So now I will quickly just run through the documentation and explain you the major concepts so that you will understand it easily. And then if you have any queries, just let me know. So let's say implementation of the thread pool, what they are doing, let mute threads is equals to vector with capacity, and then they are creating the size, create some threads and store them in the vector. So we have to implement something here, and then a worker struct responsible for sending code from the thread pool to a thread. So how we can do that? Here's the new process that will happen when we create a thread pool. We will implement the code that sends the closure to the thread after we have workers set up in this way. Define a worker set struct that holds an ID and a join handle. Change thread pool to a hold vector of worker instances. Define a worker new function that takes an ID number and returns a worker instance that holds the ID and a thread spawned with an empty closure. In thread pool new, use the for loop counter to generate an ID, create a new worker with that ID, and store the worker in the vector. So here you can see workers vector with capacity, and then they are looping over the size. Let's say starting from 0 till the size, number of sizes, threads I want to create in. So now what I am doing, workers dot push, and I'm creating a new worker here with the specific ID, this thread number, and returning the thread pool struct as worker. Inside that worker, we have ID and the thread. And then inside that thread, we are creating a new thread, and then you can implement this directly inside here instead of creating a new struct, whatever you want, prefer. So this is the best way right here. We have changed the name of the field thread pool from threads to workers because it's now holding worker instances instead of join handle instances. We use the counter in the for loop as an argument worker new, and we store each new worker in the vector named workers, and then so on and so forth. So let's just quickly run through the documentation and go at the end of the documentation. And here, this is the pretty much the worker instance. So implementation of worker, we are getting the ID as a function parameter, receiver, and then inside that receiver we are applying the locks. So let's say if a thread is in let's say if a thread is processing a request, so this thread should get locked, and no other connection can use that specific log or uh, impact the processing. So now MPSC, the multiple producer, single consumer, receiver, and then the job, and then it's returning the worker. We have a thread spawn receiver dot log dot unwrap dot receive, and then the worker ID get a job executing job, and then so on and so forth. So this is pretty much it from this, and graceful shutdown and cleanup. Okay, let's just make. So now, because we are directly panicking our web server if there is any error, so now what they are doing, they have implemented the drop function here, drop worker in, so that we have to shut down the worker whenever it's completed. Worker dot thread dot join and dot unwrap. So move due to this call, so we have to implement the. So here you can see move occurs because worker dot thread has type join handle which does not implement the copy trade, and they are explaining however the only one time this would come up would be when dropping the worker. In exchange we would have to deal with an option thread join handle and then so on and so forth. So they have implemented that, signaling to the threads to stop listening for jobs. So now here the basic purpose of this, so let's say if it's kind of signal that I'm currently uh, processing some requests, so I'm not available for that specific task. So l- just recall the words that we have um, read a while ago about we have we have to inside the thread pool, the threads will signal whether they are ready to accommodate the request to work on that task, or instead they are not ready or they are working on some other request. So this is pretty much it. Thread pool new, and then the execute function here and the drop function. And here you can see now what they are doing, dropping sender closes the channel, which indicates no more messages will be sent. When that happens, all the calls to receive that the worker instances do in the infinite loop will return an error. In listing means this code, we change the worker loop to gracefully exit the loop in that case, which means the threads will finish when the thread pool drop implementation calls join on them. So now here you can see receiver dot log dot receive, and then they are matching over the message. If the okay, there is an okay this block, so you can return the job, else you will worker ID disconnected, shutting down. So let's say the work instance is being shut down, so you can directly break the loop, the this loop right over here, and then you can exit it. So here you can see they are running the code. Worker 0 got a job executing, shutting down worker 0, and then worker 3 get a job. So it's working like a sequence of request, accommodating thread is working on that request, and so on and so forth. So this is pretty much it. This is the overall code of lib.rs. If I want to run the command or the code, here you can see if I want to, let's say, run the, let's just copy this piece of code here. By the way, I have already implemented that. So let's just quickly take two requests or the threads right here. Let's just quickly run the command cargo run. Here you can see multi-thread web server running. And then what if, let's just quickly open this side by side. And let's just open the Postman here. So let's say, okay. And then, so here you can see worker 1 got a job executing, shutting down worker 0. Worker 0 got a job. Here you can see it's refused to connect because the worker is shut down. Shutting down worker 1, worker 2, and worker 3, and the server is exited. So now let's just go back to the documentation here. You can see we could do more here if you want to continue enhancing this project. Here are some ideas: add more documentation to thread pool and its public methods, add test if the library's functionality you can implement the test functions of the library grade. Change calls to unwrap to more robust error handling. Instead of unwrap, you can use match statements and return the custom errors. Use thread pool to perform some task other than serving web requests. So this is the pretty much uh, custom implementation of a web server. If but for real or the production application, you will be using a framework to build a web server. So no worries about that. If you didn't understand anything, just let me know. I will try to explain each and every concept by hands-on implementation, by creating separate different examples, which we used to do. And then somebody, well done, you have made it at the end to the end of the book. We want to thank you for joining us in on this tour of Rust. You are now ready to implement your own Rust projects and help with other people's projects. Keep in mind that there is a welcoming community of the other Rustaceans who would love to help you with any challenges you encounter on your Rust journey. By the way, we are not ending our Rust journey because now I have some plans afterwards. So after uploading this video, I will, because there is a surprising video for you guys if you haven't worked on that. Because let me just reveal it for right now. So what we will do, I have prepared a plan. So now, because we have already covered the basic hands-on implementation of the concepts that we have learned, like we have built front-end application, back-end application, we have built the CLI application with clap crate, we have built with custom Rust code. So now we are fully prepared, and I'm getting a lot of requests and queries about when will you start the blockchain development. So I have planned that from now on I will start publishing or uploading the videos about Web3, blockchain, and more specifically about AI. So now in our next video, we will explore how we can build or integrate LLMs in with our Rust programming language. Might be you have heard about that, that you can work with LLMs, or you can integrate LLMs within your Rust programming language. How you can do that? So we will explore that in our next video, and then after the after that AI part, we will go on to the theoretical, because I'll try to uh, start with basic understanding the theoretical explanation of what blockchain is, what cryptography is, why there are different blockchains, means why there are different concepts inside that blockchain, like decentralized DeFi, you can say decentralized finance, what is NFTs, what are cryptocurrencies, why it's being important amongst the blockchain developers or the blockchain community over there. Now, and then we will learn about how we can build our cryptocurrency. We will understand how we can write smart contracts, how we can get deep dive into the decentralized finance. So, if you have any plans of going into any of the directions you want, you can explore the upcoming videos too. And if you want, you can share it with your fellows and friends. And so this is pretty much it. And I have already shared the roadmap with you guys. So stay connected, stay tuned, and then this is pretty much it. I didn't haven't written uh, a post on the uh, about any of the previous videos. So I have only written the post about the WASM and the front end frameworks, and after that, I haven't posted something on the socials. So because I didn't get any ideas to post, because I don't want to just write it and post it. I just want to post the quality content on the internet, not just get the content from AI and then post it. No, I don't want that. So I don't have any thing from socials to share with you guys. So if you have any feedback about my videos or for any upcoming videos, you can for sure share it with me on my directly on my socials if you want, or you can directly drop it in comment box. I would love to hear about the feedback. And if you have any queries, questions about the any of the Rust concept, you can please do that. It will help you learn and get deep dive into the programming, Rust programming. And if you will give me the feedback about my videos or anything, this would make it easier for others, and it will help more developers to get into this Rust community. And then this is pretty much it. I hope you have learned a lot of stuff from today's video. This was the most of the part was theoretical. Explanation of the concept was TCP, what TCP is, what HTTP is, how we can work with thread pool, how we can manage the multiple threads at once, how we can accommodate the backend server, the backend connections over the thread pools and so on and so forth. So this is pretty much it. And if you have learned anything, you can just share it with your fellows, subscribe to my channel, like, follow, whatever the formal procedures are. And this is pretty much it. So till the next video, bye. Be productive, be safe,